As you can tell, or if you've read the overview and looked at my, even the GeoIQ where I work, obviously I'll talk a lot about mapping, but mapping as it applies to a lot of different things. So my name, if you haven't met me before, is Andrew Turner. I'm the CTO of GeoIQ. My background is actually, I used to be an aerospace engineer working on satellites for the European Space Agency. And I got fascinated, I got a little frustrated with, talking about industry that's big and behemoth and moves very slowly. 10 years to work on a project, maybe it blows up the launch pad. Thanks, let's go start the next one. But I got fascinated with how to utilize the data coming from satellites and put it in the hands of everybody to be able to understand their context around them. So that's been going on for the satellite industry for a very long time, but in the web now, the volume of data we have is amazing, and not just the volume, but the wealth of it in different ways to look at that and be able to, in some ways people actually refer to swimming through the data, be able to see it and play with it and do different things with it is pretty amazing now. Whereas, again, 10 years ago, just getting the data itself was incredibly difficult. So you had an idea, you wanted to experiment with something, spend most of your time just getting the data, and then maybe be able to ask a question, one or two questions for it, and then you had to move on to the next aspect. So that amount of data and just at our fingertips is amazing. And even just kind of seeing what it kind of looks like. This is an open project, a project called OpenStreetMap. And what happens is they crowdsource data. These are actually people going and tracing GPS or deriving road data or infrastructure data around the world. And this is actually 2008, so this is even 3 years old now, but just look at what's going on every minute. This is actually, there's a time slider down here by going across months and days and months, but the amount of data that's being generated continuously, and it's all completely open. And this is just one data source. Now this is an incredibly rich data source. I mean, in the end, I think there's like 3 or 4 billion triples, essentially, of nodes connected to nodes with attached attributes. I mean, huge amount of data that serves a lot of possible analysis as well, but also represents just a lot of other data that is available out there for us to kind of start diving through. And then what's been going on the last 2 or 3 years, and I live in Washington, D.C., so some of my examples will focus around D.C., but the amount of open government data, this data that we had to go and do FOIA requests, Freedom of Information Act requests, go and pull up from esoteric formats, which are still kind of out there, but these data catalogs have been popping up all over the place in the US and as well as Europe and Asia and in Africa even now. Just Kenya, the government just launched their open data portal or open government finance data, so a lot of data is being shared out there and most of it's being updated pretty well, but it's pretty accessible, and there's a couple hundred data sets that, for example, just DC, so not even real estate, but this tiny 10 square mile area is publishing out crime data, 311 data, income data, historic maps back to the planning from the 1800s and 1900s. The data is all accessible via KML and RSS feeds and spreadsheets and all kinds of different formats, so it's there in these great catalogs. So we can go and dive through these huge lists of information. And then just looking at the other ways that data is being gathered, so not just very expensive satellites or government data, but the amount of mobile information that's now being made available. And just looking at it globally, it's 80% of the world live within cell coverage. So they're able to connect, make a call, send an SMS, and even 50% of the world own a mobile phone. So huge possibility of integrating and connecting into digital data and pushing this data around and querying it. And then this is a diagram from Jeff's 3 design company that looks at the geosocial universe in particular, about people connecting through social networks, pictures, the location of pictures of their cats. For example, take the example from this morning, where just the amount of data, 5.3 billion mobile devices are being pushed, are available through all kinds of different social networks. People are engaging through these. So you can imagine now being able to look at a city and not just see that here's where the people in the city are, but each element of that city is starting to publish out and stream information, sensor data, location, temperature, health, speed, road quality, inventory amount, sales, POI, all this data is being constantly streamed out through numbers of services and feeds and APIs, which is amazing. Again, more of this data we can start latching onto and layering together. We did a project last year actually looking at Black Friday, it's the day after US Thanksgiving, where people go on huge shopping sprees. And this was just grabbing Twitter data, people mentioning Black Friday or Walmart or shopping, just people publishing out and streaming out publicly what they're doing, what their intended purchase was, where they're doing that data. And just kind of see this kind of stream over time and not only form metropolitan areas, so it's not surprising necessarily. You can see some highway areas where people kind of along certain roads might have a lot more Walmarts or Best Buys or something like that. But what was important and interesting here is just had an idea, wanted to measure it, set up a stream and start gathering that information. So the ability to gather that's pretty amazing. But then you start pointing at other information behind it. So every Twitter here could either have location either attached to its metadata of the message, could have it inside the message itself in the copy text, as well as someone's profile location. you start linking those two things together, you don't understand just where people are doing what they're doing, you understand maybe where they came from to do that activity. So this is just looking at kind of where people's nominal profile location was, and this was just a lot of experiments, not taken for quality or error control, but just thinking about where people are coming from Japan to come to New York to start shopping. And this is all data that's made publicly through, in this case, the Twitter API. But then looking at a lot of the personal data that's now being shared out. So Alistair will actually recognize this. I didn't put it in his specifically work, but the iPhone tracking location information, where Apple had on there where they're automatically capturing location, storing to your computer, synchronizing back and forth. This is actually a German minister got his records publicized about where he was, the cell tower he was seeing, people could play through time and see all of this information. So what's fascinating here is not just possibly the invasion of privacy or personally identified information. That's been going on for a very long time. What's different now is the fact that you can have a nice dashboard about it. I can actually play my own history and see what that is and start understanding maybe perhaps my own trajectories through time, how I'm moving, how other people are moving around me. There's a couple great products out there which are aggregating together this information and making even those anonymized aggregations available to analyze that data. So this is potentially very personal information. The thing I carry with me that I probably have with me more than I have on a pair of pants is now tracking this information, and I can actually pull it in and start querying it and analyzing it. So the interesting thing, and the purpose of what I want to talk about is just how to deal with this data. So we have a ton of data, right? Simply put, big data, lots of data, string data, unbounded data, mobile data, personal data, just a lot of it. So the question becomes is, how can we actually deal with this data? I mean, there's a lot of different tools out there to possibly provide us a specific interface for it, like bar chart or something like that. But I want to kind of go beyond just the, that I have access to it or someone's giving me their own perspective on that data. So we first need to make this data is accessible and relevant to people. So just as much as people don't want to care about the underlying format of the data. So USB has a lot of complexity, a lot of standards behind it, but I can just plug it in my computer and I get data that was on this thing and now it's on my computer. Something that makes sense to people, now the data they can share with one another, economic data or video data or any of this other data, is simple, and the kind of technology dives away, but they can carry and utilize it how they want to use it. They don't necessarily need to, they can pass off something, they can mail it to one another, they can just use it in numerous different ways. So once they start sharing the data, now it's starting to look at the way people are visualizing this data. And there's a lot of galleries of great visualizations out there. So flowing data is one in particular. Nathan Dow's done an amazing job over the last number of years gathering together ways to be able to slice and dice this information to kind of exemplify interesting ways to view and understand that data. And share it out there. But the problem is that a lot of these are static, right? There's a chart someone's made, they give me their perspective on it, and then what else can I do with it? I'm kind of limited with what I can do with it. I can go and embed that picture, talk about it, blog about it, but we've now been removed from the data itself and can't do anything else to kind of experiment with it or do any derivative analyses with it. So the tools themselves are often very difficult, at least for people who aren't tool builders or developers or statisticians. So the tools require a certain amount of expertise and training to be able to start utilizing, access the data, query it, get it out, and do something with it. So while we might have the data, we have the data at hand, what can we do in ways to kind of explore it in ways we hadn't been able to do that before? So I want to highlight 3 basic principles, and I'll show you through a lot of these examples. And the capabilities that kind of form, like how do we actually make this data relevant and in the end so people can kind of play with it. So the first, as I mentioned, was that open access to data. So the data is open, accessible in formats that, not the format itself matters, but the fact that I can pull it into numerous other kinds of tools. So if you're familiar with KML did this for geospatial data, but APIs are pretty good. The problem is APIs tend to be unique between each API, but at least I can maybe wrap it around something and get access to it. Providing tools to visualize that data, so being able to quickly be able to push on charts, push on a map, and be able to see different characteristics around it. And then what's in the end is actually be able to analyze it, be able to ask questions of the data, be able to get to correlations or different ways to view that data, and actually get to some kind of answer. So not just where I've been, but what have I been doing there, how does this compare to other kind of data? And so to do that, a lot of things we look at are end up being through the power of place, being able to layer together data geographically. The amazing thing about location is eventually you might have a semantic web where I can link and know that this person is this other person, or that I mentioned a neighborhood, and also means it means semantically that it's within another state. But geography right now is a really great way to do that, because once you compress together this information, time and space, it's related. So there's something called Tobler's first law that 2 things near each other tend to be more related because of actually geography and distance. And what's amazing about maps, beyond just the fact that you can start layering them together and get these kind of at least visual correlations, and I'll show you some analytic correlations, is that maps themselves define and reflect reality. We're very good at looking as human beings at seeing these maps, identifying patterns, and then having those, what we see there, actually define reality. So bonus points if anyone knows what this map is, besides someone who raised their hand about the being a mapper. Anybody else? Waldseemüller, 1507. Ring a bell?
Yeah, it's the map of
So this was the first map, as Skylar said, that mentioned the word America. So on the map, it was a cartographer, Waldseemüller, actually had an incredibly accurate prediction of the land. This map actually is accurate to within 70 kilometers, just a very, very odd projection around the equator. So it's actually incredibly accurate for the time. And there was this land out there based on the numbers of records that he said, well, I'll take Amerigo Vespucci, I'll put it in Latin, Americo, and I'll give it the feminine America. And we named America, and then from that we now name our lands, North and South America, from this. The map itself defines that reality, but maps themselves can also be non-cartographic in nature, and so interesting ways to visualize the data. So there's a story mapping, which actually is literally how nomadic tribes...
What was the name that made that map?
The Waldseemüller?
Well, yeah, Waldseemüller.
Yeah. Actually, that's a good point. This is one of crowd. If you have any questions, feel free to ask them. You can make it more interactive if you want to. So story mapping is where people, nomadic tribes, actually tell each other how to get from one place to another by actually telling stories about the routes they would take. About the demon in the mountain to the east, gave way to the goddess of the river. And these nomadic pathways were how people shared that information between one another. And then what people started to do is also experiment with different ways to start understanding the information since it was relevant to them. So that stick charts, this was Polynesian kayakers that would go between islands, couldn't see the island over the horizon, so they needed to be able to read a map where there was no other geography to see. These actually describe the wave patterns you would see from the island over the distance. So if waves come certain one way and they intersect with another one another way, that means there's an island in the middle of them, or there's two islands to the east of those. So this way to kind of pull it, make this data relevant about wave, could tell them about where the islands were, where they're coming from, where they're going to. They also floated, they were reproducible very easy, so a lot of ways to make this information relevant and usable. And then travel guides, so different ways people wanted to, in the end, share this information with one another. So once you were making these maps about these places, people wanted to understand what the rest of the context was there. So show me images, show me stories, maybe a historic flicker kind of idea, but people wanted to be able to socialize this data between one another to kind of reach some kind of consensus. So stepping out of history specifically is what we end up with are a lot of different tools to start utilizing maps specifically as a way to analyze a lot of data. There are a number of typical GIS or geographic tools to do this, but I'll just kind of highlight a few specific ones. And Elisa talked also a little bit about some of the open source libraries to be able to do this. There's tools like Geos, JTS, PostGIS that can do these operations for you if you don't want to go and run them yourself. Also, R has spatial libraries to do these things. So it's good to understand the principles behind them, but not necessarily have to go and write them yourself. So one really useful tool is something called spatial aggregation. So if you look at a map, and someone in this room also, I think, was the one that coined the term red dot fever, but a lot of maps have just tons and tons of dots on them. And it's kind of hard to see what's going on, what's the pattern going on here, because this, I think, in particular, are Starbucks locations in Manhattan. So what we can do is we can actually go and run through a quick analysis, ask things like, do you want to aggregate by count, do you want to aggregate by sum or value? What values do you want to aggregate? Like you might do a roll-up in a database, but then do it to a spatial boundary. So this is actually a census block in New York City. So now you can start seeing emerging patterns happening beyond just, I have a ton of points. I want to see, oh, okay, so there's ones, and sorry, I don't know my New York neighborhoods, right? But there's ones, I think that's around Central Park, makes sense. But ones are on Battery Park, I think, on the southwest, or I see it's a high tourist area. So you can start seeing these patterns, and in that case, start asking questions about that. Another one is something called spatial correlation, where you then take that data and you compare it against another attribute. So let's say, this is where geography is really nice, because I can start asking questions like, is there a correlation between number of Starbucks and median income? Because I put them both into census blocks. Census block had median income, the Starbucks had count or sum of sales of those. I can compare those two things together because they're in the same geography. Essentially, I've linked them. By doing that spatial operation, I can now predict, I can at least understand if there's a correlation there. Maybe not causation, but maybe there's some other correlation going on there. Let's see between these. So this is actually Old Navy tweets from Booty Appreciation Weekend. I don't know if anyone saw this. It was, you went into Old Navy, said, I shake your booty or something like that, you got a discount. compared to actually Old Navy stores. So in this case, is there a correlation between people that tweeted about, shaking their booty and actually where the stores were located? Was this helping or inversely proportional? And then another one is just more general ones is spatial distance and filtering. Again, this is looking at metro line locations, but usually you want to ask questions like distance to the metro line or those, how far away is that? So usually giving a distance between those and then being able to calculate a buffer around those. Is that kind of common term? And then lastly is intersection. So looking at maybe the buffer between those two things and seeing what they intersect, taking that there's, say, high crime rates and seeing where are those intersections between those two elements that happen together. Maybe there's a place you can investigate, recommend to somebody, or whatever kind of operation you're doing. So, and there's one other one is where just doing user-defined analyses. So we've been experimenting a lot with tools, and we'll talk a little bit more in depth, but utilizing GeoS, PostGIS, and Hadoop underneath to allow people to run these analyses over large data sets, but also be able to plug in their own analyses. So where people can go and arbitrarily pull together these different analyses, they can actually go and type in their own equations. So ask questions about summations of values. I'm just looking at actually summation of population counts from different tribal affiliations and pulling them together in Afghanistan. So where are these spatial things become particularly relevant? This is actually looking at traffic accidents. So a kind of common thing might be to say, well, I want to see if an intersection is safer. This is something often asked about, like, say, in insurance or by governments about safe areas. So, wow, there's a lot of accidents along roads. There's a correlation in there. So it's kind of overwhelming to even know what's going on. So one example of work at a company called Virtual Vehicle, what they're doing is they're actually taking not just traffic accidents, but also taking traffic flow amounts and rates. What they do is they buffer the two out, they intersect the two, find out where along any road segment where those two overlap, and then essentially they're normalizing. So calculating the normalized value of number of accidents by the actual traffic data. So taking from different DOT with AAA, with different data sources, combine them together, and then what you can calculate then is this kind of crash likelihood density value. So not just there's accidents happening, because if there's one accident amongst a million cars, not as big of a deal. If 10 accidents amongst 100 cars that pass along that road, it's a really dangerous intersection. So you can see here, just kind of roughly as a quick pass, where there are possibly very dangerous specific intersections. So that's going to the government saying we need to fix traffic light areas, telling to pedestrians, I'm just not going to route you along that path. For houses, like you don't want your kids crossing that street along the data. So that's just kind of one really quick example about how to mix together these spatial operations to get to a specific analysis about, okay, here are the locations that matter, are important based on this question. So, but this is great. This is good for governments, it's good for statisticians, it's good for insurance companies. But how to make it relevant to people? Because in the end, people are the ones that live in these neighborhoods. Right? We work a lot of us work in the consumer space. We want in the end someone to pull up their mobile phone and ask these questions to see what that looks like to them. A couple years ago, I wrote a book for O'Reilly called Introduction to Neogeography. But that idea of taking these possibly really advanced concepts and tools, putting in the hands of the average person, this is what I was passionate about coming out of spacecraft design, was how to put it in the hands of that person, because they're the ones that matters the most. When they have their kids, when they're planning their travel and vacation, how to put it in the hands of that person to be able to ask those questions. And you combine that at the same time, this is happening a couple years ago, with this concept of psychogeography, which also people's perception of place. This is actually, Christian Knoll did an experiment where you put galvanic skin sensors on people's fingertips to measure happiness and a GPS trace. And as people walked around, they measured the levels of happiness and unhappiness. This is along the Thames River. So you actually got not just the, is it dangerous or not, but what are you feeling? Is it good or bad here? So combine the hard data with the kind of more qualitative data, but actually put a quantity around it. So what are people feeling around this data, and start combining those two things together to get perception of place, land use planning, things like that. So getting finally to all these tools, how do we actually put them in the hands of people themselves? How do we enable these kind of playful explorations? So we work at an open website called GeoCommons. Essentially it's made to enable people to do a lot of this experimentation with data and visualization. So on the site we have, this is crowdsourced, anybody can upload data, pull in open government data. We have almost 600,000 geographic attributes available. Anybody to be able to play with that data, and anybody can contribute data to LinkedIn feeds, and I'll show you an example. So it's a huge community of people being able to play and analyze and share all of this data. And then as I mentioned, being able to layer these different pieces together. So visually and then analytically being able to pull these different pieces together. So, so I was kind of interested in saying, well, we have 600,000 possible attributes to measure. This could be income levels, number of Twitter followers, Again, accident rate, number of injuries, number of cars involved. So I took the 590,000, did a combination on, assume just 2 layers. I want to compare one layer to another layer. And you end up getting 174 billion possible combinations just from this one public data source of possible interesting correlations you can start having. Now, that's a really rough number. I mean, close enough. I mean, a lot of these numbers you could say, do I really want to know the number of Twitter followers in Iowa compared to, how much the minister is paid for in Kenya? But, there's different ways you can dive into it. And the nice thing is if you let somebody actually ask that question and see if there is something there and at least possibly start diving through. Just kind of one quick example, someone went and made, this is looking at geotagged Flickr photos with the actual Flickr boundaries compared to Crunchbase funding amounts. The kind of question you might want to ask is, is there a correlation between people with digital cameras uploading to a social media sharing site compared to the amount of money being put into companies? Right? It's something that takes somebody 5 minutes to do and be able to ask that kind of question, then socialize it, vet it somewhere, talk about it, share it out and ask that question. So, so I talked about this open access, this visualization, and this analyze data, but what is interesting to see when we start looking at what is that like in the hands of actual people, and how are they kind of playing with it. So kind of here's one example of just what it looks like kind of going through a map. And just want to do myself. I want to look at, I just moved to DC and I want to see what it was like where I moved to DC and how that compares to, is it safe or not around that area of DC and kind of play with it. So I can go and grab my Foursquare RSS feed, add that in, and quickly add that to the map, pull out all that data behind it, make that available. It's already public data, so I don't mind keeping it public in this case. So once I've added, you can actually see I was recently at the shuttle launch, which is quite amazing. But I'm interested in this case to dive into Washington D.C. And see specifically around D.C. what that looks like. And the idea of letting anyone kind of play with this. So bring the Foursquare icon so that people know what I'm talking about when I share back out. And then I wanted to start diving in and start comparing this to other information. So in this case, I want to go and pull in my Twitter feed, which I saw Rafi around here. Twitter's been hiding our RSS feeds. It's a little difficult to find. So be able to pull the Twitter feed, and I tend to geolocate my Twitter messages a lot. So be able to pull those in, and same thing as add an icon to those. So this is pretty simple though. Just being able to take all my social media data out there, pull it together at first, and just be able to see kind of a dashboard of where I've been, what I've been saying where. So at the very least, it's my own little personal where things have been, but that's kind of the first pass of building my own possible history of what I've been doing. So I can look at DC, okay, where places I start hanging around DC, maybe start understanding that better, but I actually want to start seeing the change over time. Do I tend to move between east and west and north and south of the city in different ways, and how does this compare? Is there a correlation between when I check in on Foursquare versus my Twittering? How do those two things compare, and see how those vary over time? Do I ever leave the city? Right now I typically don't want to go out to the hinterlands of Virginia. So seeing that, but so this starts getting interesting. But I start want to pull in some government data here and see how that might compare. So I'm just going to speed this up a little if I can. So I can start pulling in some government feed data. So the DC publishes out crime data as a feed. So I can just add that in, compare that as an RSS Atom or GRSS Atom feed. Be able to pull that data in. Although you'll see in a second that it's questionable how often they're keeping this up to date. So I think I need to go and send them an email about this. Also, there's a lot of quality. You'll find out with a lot of obviously public data if you've ever played with it. A lot of outliers. I don't know why there's DC crime happening in Antarctica. Egregious criminals, or in the center of Arlington Cemetery. But you see, essentially, DC has some pretty rough areas around the city. Gaps where there are parks. That makes sense. Although at least probably reported. And you wonder here, also there's this gap here between 2010 and 2011. I don't think it's gotten that much more safe of a city in the last year. I think they're being a little lax on how they're publishing the data. I know they've changed for some privacy reasons on the data. So now I can start seeing just visually where those two things start comparing, where the crime compares to places I might want to hang out. See that over time, see as it changed between now versus last year when I started comparing those two things together. But I actually want to get a little deeper behind. It's just a huge data, right? Again, that red dot fever of just tons and tons of points happening. So what I can now do is pass through kind of any of these analyses functions, letting anybody play with them. In this case, I want to do a filter by distance. So equivalent, I want to do a buffer and an intersect to those 2 points. So I want to buffer out, in this case, I'll buffer out my Foursquare locations and intersect those with crime data. And I'm curious, in this case, I want within a mile, roughly. Although you can actually go and filter that data. It's interesting, again, we can kind of play with the data afterwards. So go quickly, push this off into a queue, call it against Geos, it takes a second to process, and then bring the result back to the user so they can start seeing, what those couple things, those correlations kind of exist between those two variables. So once those come back in, you can start seeing that, the density of those locations there between those two. So you can start filtering down again, filter by time. And I've gotten down to a very specific filter of distance. You can even go play, miles a little too far. I'm going to filter down to half a mile. Right? So this is using all just using those open source Geos libraries to pull the data back and let the users kind of then play with and explore that data. And then getting to actually socialize this data, I want to do more than just this. There's a URL I can email that around, but usually what you want to do is then socialize it. Kind of like those historic maps about sending them around to different people, is to start sharing that data out with others. So you can actually go and embed this map. So go and give a description, embed the map in a blog, or I can actually go, in this case, actually just go and embed it into Facebook. And that's the thing about Facebook, it's pretty easy if you add some meta tags. You automatically start embedding visualizations such that they stay live and play with it. So being able to then socialize that result and share it with other people around, start being able to share it around. This has been interesting also, is sharing out visualizations. This is the first time I did this when we were buying a house in DC, and my mother actually started weighing in on where we should live and based on crime and access to microbreweries and things like that. So it's interesting then when you start getting, if my mother starts engaging with something I'm working on, I know I've crossed a certain chasm there. And Facebook's helped do that, but being able to put that visualization in front of her, I have a little bit more knowledge. I can click through, get the data, and push it in front of her to be able to play with. So it goes beyond just citizens. You can go to government. So just kind of playing around. This was an experiment someone did with comparing Foursquare check-ins compared to Metro Station. What are more popular ones? What are probably ones with better cell coverage? Where people are stuck in for longer, so they actually have time to check in. But looking at different ways to tie social media to government infrastructure data. Or similarly, working with the World Bank on being able to explore the 16,000 locations they're working in. They actually had to go and pull all these out from PDFs and then publish them out in open data formats, compare that to underlying indicator data. So now people can explore and understand, in Kenya and development agencies and academic can go and understand, say, correlation between World Bank funding of healthcare products compared to needs such as infant mortality. Or the best thing you actually can end up doing for healthcare is actually start building roads, so being able to compare roads compared to health facilities compared to need.
Is this still GeoCommons?
This is all GeoCommons, and this is using relevant to here is this is using a library called Modest Maps, is the actual visualization library, and Polymaps, which I'll show actually more an example. But this is all using GeoCommons API underneath with all public data. And then looking at what media, because once you pull this tool, it's fascinating what media starts doing when they start playing with this, because they have want to start essentially doing story discovery out there. So you have places like the Calgary Herald, they went and looked at dog population compared to neighborhood. A number of dogs, is there an area where it has more dogs, it's maybe more dog friendly or not, and sharing this data. So using GeoCommons to pull in the data and share that out. Or in this case, looking at most ticketed areas, actually comparing ticketed areas to income to coffee shop locations. People in high-income areas get less tickets, so they get more tickets because they're going to just accept and not challenge paying more for that ticket. So start sharing these out, embedding these, letting people kind of play with those. So they're not static anymore. People can explore and dive through that different data. And then I mentioned, what governments can do with social media. This is actually, we started latching on to a Twitter stream about Tahrir Square on January 25th, and just seeing who's talking about what around the world, passing through a sentiment engine to even get some rough pass of sentiment, extremely rough, but positive, negative. So not only the bigger the circle, the more positive the sentiment was talking about the event. But what you can actually do is, one, you start seeing this happen, and then also there's an explosion when Mubarak stepped down. So all of a sudden the whole world wakes up and starts talking about that. You can start doing, there's some people went and then started playing with the analysis from this data and started looking at this compared to failed states and predicting failed states. And you had a pretty high correlation between people that were talking positively or negatively about these to ones that started going afterwards, such as Yemen. So that was kind of interesting to be the indicator on that data. So science, when you start publishing out science data, it's pretty amazing. There's a lot of different open data science formats, but this is with climate research. A lot of times we're told by scientists that it's getting really bad. That we're going to be flooded, it's going to be, climate change is horrible. But if you don't let people play with that data, how are they going to know what it means to them? How bad is it? What does that look like possibly in my neighborhood? How is that going to affect my house and my park down the street? So work with the World Wildlife Fund, publish out ClimeGen, and ASCII grid data sets of moisture data, air quality data, surface temperature data predicted over the next 10, 20, up to 100 years in the future. People can play with and start mixing and matching these things together. Again, vacations I'm going to be planning, how's that going to look like? Maybe I want to get more involved or buy a house in a different area, or governments can take this to their citizens. So different ways you can kind of converse around that. Looking to developers specifically, there's a really great tool set out there. We work with a group called Accelerator. They built an open source mobile development framework. You write JavaScript and it deploys to iPhone, Android, Windows Mobile, I think the WebOS. So what people can do is quickly write JavaScript, deploy an application. What happens on the backside is that every single time someone uses a mobile application, or as a request, they can capture that event, and capture that event, pull that all in to historic logs over time. What happens is not every single one of them has a location attached to it. So we actually use Hadoop to go over this what we call geopacing, which is actually take the one location we have and apply that location to the other events. So at some point, if you ever open a mobile phone application, it says, do you want to use your location? Yes. Use that in search, but every time then after that you actually do a search, you look at a result, you get a navigation, you post to Twitter, you can attach location to where you even did those events. So you can then go and push this all over into HBase and then combine it possibly with other external data, such as, again, access to metro stations, possibly sales data, and then let developers themselves go and build up maps to understand the impact of their mobile phones, kind of a mobile phone analytics to see what they're being used and how it actually results to their clients or to their users. For example, we did it for one, anonymized it, but I was looking at a pizza company doing a mobile phone application serving out coupons. And they can actually go and look at, so when was my coupon served? When did somebody open it? How does it compare to my stores as well as my competitors' stores? Because you can get a lot of that data online. And then actually look at my internal coupons redeemed and start diving through experimenting with that data, how it happens over time. Should I be serving out more coupons near my competitor stores or where there's none of us? Or just around my stores because they're going to come into my stores? And then compare that again against underlying other data such as demographics data, how they get to work, do they bike, do they metro, do they bus, do they drive to work? Start looking at that different data and allowing them to experiment with it. And then we use a library called Polymaps, which is SVG based, to actually let people go and view these and actually build their own analyses on mobile devices. So people can go and layer together this information, build an analysis, and then share that with their client or with their users. So essentially performing mobile analysis on mobile devices themselves. So then looking at actually how enterprises are starting to mix and match this data. There's another example of kind of looking at just for the Oscars, how people were talking about the various Oscars, the actors, the movies, over time, and compared against sentiment, compared against demographics and maybe income levels. You started seeing some pretty interesting things. In this case, it was looking at Black Swan, I think, in Natalie Portman, if I remember, and there was kind of median feeling, and then you just look at just Natalie Portman, and there was a great sentiment, and Black Swan was a poor sentiment, right? But you can actually look at how this plays out across the country. So you start seeing interesting demographics by comparing, say, against race or income, what kinds of movies they liked, and actually dive through underlying after you disaggregate it, see, okay, what were the actual messages people were sending? How was they? Actually, in this case, a lot of people loved Natalie Portman. They loved her actually because she was pregnant. So it was just interesting, understanding even that intent and sentiment behind the scenes of why these things were going on at a high level, and then be able to drill in and look at a very low-level aggregated level. So kind of highlight just a lot of these kind of different ways people are using this, tools like this to be able to share this information. But so it's pretty amazing that they can use essentially geographic data and open data and tools to ask questions of these different domains. Then in the end, the mobile developer can go and pull in climate change data behind the scenes and provide a view for them. They can also go and maybe pull in social media data, dog walk areas, things like that. So just kind of to highlight at the end, just what some people, just in the last couple of days, how people are kind of been playing with it. This was someone went and created a hotness density map. And I read the title, and I assumed it was actually, we've seen a lot of people were trying to find hot or not bars, but in this case it was actually because of the heat wave. They did things like hot like your mom, unbelievably hot, wow, wow, chicka, wow, wow, and such. Yeah. So, but people are creating actually. This is the actual person who created this is actually called the Hotness Committee. Just went and created this data and started publishing this online to start tracking over time what the heat wave index looked like. People could go and then dive into their neighborhood and do that. To look at health, so someone went and created, in this case, obesity or state related to beer consumption, right? So everyone says, cut out the beer, but actually is there a correlation maybe by type of beer, light beers, rich beers, Oregon's doing pretty darn well. Actually beer consumption, which is a little sad too, but as well as obesity rating. traffic and caffeine. I mentioned traffic accidents, but maybe what causes those traffic accidents? Let's find some correlation. Someone mentioned on a blog post, wow, there's a lot of Starbucks. I wonder, Starbucks probably cause accidents. Someone go create a map around this. It's actually interesting. There's actually a little bit of an inverse correlation. So the lighter the color, actually, the fewer, the more inversely proportional is to the number of Starbucks compared to the darker color. And at least the theory is now, kind of having talked to other people, is that people actually, Starbucks are where people don't drive. They tend to walk to Starbucks. So there's less accidents there, maybe because they're in denser areas versus higher volume traffic areas, right? But it's that kind of experimentation. So we can ask a question, Starbucks traffic, take a couple minutes, make a map, kicks off another discussion. Let's pull in traffic volume. Let's pull in other information. Maybe Starbucks isn't that popular. We should pull in Caribou or something else like that. And for the pending zombie apocalypse, you should just really be careful about where the zombies are and where they're planning to live based on access to brain clinics and things like that. This is pretty amazing. This is, thanks to HTML5, you can start bringing animated icons, right? So I think there's a future now in even being able to see animations themselves embedded into these visualizations themselves to have really, really deep amount of information to you. So I kind of did a high-level overview of these things. If you want more technical information, actually go and do some coding underlying. Chris Helm, an engineer at GeoIQ, is speaking on Wednesday at 5 p.m. He'll actually give you code examples, kick off some streams, and do some of the things here I've done under the hood. But hopefully it was informative and kind of got you inspired to go play with data, experiment with it. Enjoy Polygon Man, jumping into the ocean. All the maps I've had here I'll post online are available online, so you can go and play with them, remix the data as much as you want.
Question, I like this work, but I wonder, a lot of statisticians say, amateur statistics, which in a way this is, you can end up really drawing the wrong conclusions very easily.
Sure.
So,
no, it's definitely true, but I think the journalism industry said the same about blogging, right? And the photography said the same about Flickr, right? And so the paradigms themselves are shifting, right? It's the democratization, if you want to use that word, right? The opening up of these tools. The best thing we found in that is that providing those tools in the open, when someone comes through GeoCommons to make a map, we show them, why would you do a quantile versus an equal interval? Now they can push a button and be done. They can also see and experiment with those things. So putting in front of them the ability to play, and that's the kind of playful exploration with these. So they're able to see what those changes are between those as they make those decisions. They publish it out, and then those statisticians can come in and they can hopefully have that conversation saying, you did this, you did it wrong. You wanted to look good, but you did it wrong in this way. Here's what you should have done. And by putting those tools available to people where they can start collaborating together, right, and hopefully start talking to one another, better they can do. I mean, this is climate scientists are really particular about this. When they start saying, when you let anybody play with the models, then they're going to do crazy things to say there's no such thing as climate change. And this is really what's going on. And the pushback is saying, no, but it's, if you want to make an impact, you need to put it in the hands of people to make it relevant. Let them tweak the model, turn the dials, keep within limits so they're not, doing crazy things like, we're going to turn to the sun in 5 years. Keep it within some bounds, but let them play with that data. And when they do something and have a question, then you can engage with them in a place they're not comfortable with because they feel a little bit more knowledgeable about what they're doing. So they'll learn over time. Any other questions? Great. Thank you very much.